Hello everyone, welcome to Module 6 of the Database Management Systems class. Today we will discuss the critical functions performed by a database management system. Upon successful completion of this module, you will be able to define functions or services provided by a database management system. Describe how a database management system handles updating and retrieving data. Illustrate the concurrent update problem and describe how a database management system handles this problem. Explain the data recovery process in a database environment. Describe the security services provided by a database management system. Examine the data integrity features provided by a database management system. Discuss the extent to which a database management system achieves data independence. Describe data replication. A database management system is an application software used to create a database. The database management system performs critical functions which are vital for the reliability and efficiency of a database. 9 of these functions are discussed in this module. These include update and retrieve data, provide catalog services, support concurrent update, recover data, provide security services, provide data independence, support data replication, provide utility services. Update and retrieve data. The fundamental capability of a database management system is to provide users with the ability to update and retrieve data in a database. Updating data in a database includes adding new records and changing and deleting existing records. In updating and retrieving data, users don't need to know how the data is physically structured on a storage medium or which processes the database management system uses to manipulate the data. Provide catalog services. A database management system must store metadata in a database and make it accessible to users. Metadata is information about the data in a database. Metadata includes table descriptions and field definitions. Metadata is stored in the catalog, which makes it accessible to users. Enterprise database management systems such as Oracle or DB2 often have a catalog called a data dictionary. The data dictionary serves as a super catalog which contains metadata beyond what has been described so far. Support concurrent update. A database could be a single user database or a multi-user database. In a multi-user database, the database management system must ensure accuracy when several users update the database at the same time. Concurrent update occurs when multiple users make updates to the same database at the same time. Avoiding the lost update problem. Occasionally, a concurrent update may result to incorrect results. This is known as a lost update. This ultimately leads to inconsistency or incorrect data in the database. One way to avoid lost updates is to prohibit concurrent update. Concurrent update can be prohibited through a method known as batch processing. With batch processing, all updates are made through a special program. Batch processing, however, creates another problem. The data in the database becomes out of date by the time the update process is completed. As a result of this, batch processing does not work in situations that require the data to be current, such as with credit card processing. Two-phase locking. In most cases, the concurrent update problem can be solved by avoiding it. An alternate method for solving the lost update problem is for the database management system to use locking. Locking denies other users access to data while the database management system is processing another user's updates. When this happens, users whose access is blocked are notified that the data is locked. The set of steps completed by a database management system to accomplish a single user's task is known as a transaction. The database management system must complete all transaction steps successfully or none at all for the database to remain in a correct state. The database management system should hold locks until it completes all the updates in the transaction. This approach for handling locks is known as a two-phase locking. The first phase is the growing phase, in which the database management system locks more rows and releases none of the locks. The second phase is the shrinking phase, in which the database management system releases all the locks and acquires no new locks. The two-phase locking approach solves the lost update problem. Deadlock. Occasionally, there may be a situation in which two or more transactions are waiting for one another to give up locks. This is known as deadlock or deadly embrace. In a deadlock situation, two users hold a lock and require a lock on the resource that the other already has. To minimize the occurrence of deadlocks, make sure all programs lock records in the same order whenever possible. Another strategy for managing deadlocks is to let them occur and then have the database management system detect and break any deadlocks. In this process, the database management system chooses one user to be the victim. Locking on PC-based database management systems. PC-based database management systems usually provide facilities or features for locking databases. However, these are more limited than locking facilities on enterprise database management systems. These limitations in turn place additional burden on the programmers who write the programs that allow concurrent updates. The exact features for handling the problems associated with concurrent updates vary from one PC-based database management system to another. These are fairly the typical types of facilities offered. 1. Programs can lock an entire table or an individual row within a table, but only one or the other. Programs can release any or all of the locks they currently hold. 3. Programs can inquire whether a given row or table is locked. Note that the Note that there are guidelines for writing programs for concurrent updates in PC-based database management systems. Time stamping. An alternative to two-phase locking is time stamping. With time stamping, the database management system assigns each database update a unique time when the update started. This unique time is known as a timestamp. The database management system processes updates to the database in order of timestamp. Advantages of timestamp are: it avoids the need to lock rows. It eliminates processing time needed to apply and release logs and to detect and resolve deadlocks. Disadvantages of timestamp include additional storage and memory space, which are required to store the timestamp values. Extra processing time needed to update the timestamp values. Recover data. A database can be damaged or destroyed in many ways. A database management system must provide methods to recover a database in the event the database is damaged in any way. Recovery is the process of returning the database to a correct state from an incorrect state. The simplest approach to recovery involves using backups. A backup or save is a copy of the database. Journaling. Enterprise database management systems provide sophisticated features to avoid the time-consuming and costly work users have to do when recovering a database. An example of these features is journaling. Journaling involves maintaining a journal or log of all updates to the database. The log is a separate file from the database, and it is available even if the database is destroyed. Information kept in a log for each trans information is kept in a log for each Information kept in a log for each transaction include the transaction ID, the date and time of each update. The log also contains the before image, which is a record of what the data in the row looked like before the update, and the after image, which is a record of what the data in the row looked like after the update. Additionally, the log contains an entry to indicate the start of a transaction and the successful completion of a transaction, also known as the commit stage. Forward recovery. If the database happens to be damaged or destroyed, warranting a recovery, the forward recovery method is implemented. In the forward recovery, the database administrator executes a database management system recovery program. The recovery program applies the after images of committed transactions from the log to the database in order to bring the database up to date. The performance of the recovery program can be improved by having it first scan the log and then apply the last after image. Backward recovery. If the database has not been damaged or destroyed and there is a problem with it, the problem must involve transactions that were incorrect or, more likely, stopped during the transaction process. the database is not in a valid state. In such a situation, backward recovery or rollback can be used to undo problem transactions. The database management system accomplishes the backward recovery by applying the before image from the log to undo their updates. Recovery on PC-based database management systems. PC-based database management systems do not offer sophisticated recovery features such as journaling. Most PC-based database management systems provide users with a simple way to make backup copies and to recover the database later by copying the backup over the database. If a recovery is necessary, use the most recent backup recovery. To ensure that you have the most recent copy of the database, you should regularly make backup copies using the database management system. This approach, although not particularly desirable, is acceptable. However, for systems with large number of updates between backups, this approach is not acceptable. In such a case, the needed recovery features that are not supplied by the database management system must be included in application programs. Providing security services. A database contains vital records and information. This information must be secured. Hence, the database must also be secured. A database management system must provide ways to ensure that only authorized users can access the database. Security is the prevention of unauthorized access, either intentional or accidental, to a database. The most common security features used by database management systems are encryption, authentication, authorization, views, and privacy. Encryption. Encryption converts the data in a database to a format that is indecipherable to another program and stores it in an encrypted format. The encryption process is transparent to a legitimate user or users who are authorized to access the database. The process of reversing the encryption is known as decryption. In Access or Microsoft Office Access, a database is encrypted with a password. Authentication. Authentication refers to techniques for identifying the person who is attempting to access the database management system. The most common authentication technique is the use of passwords. A password or individual password is a string of characters assigned by the database administrator to a user that must be entered for access to the database. An alternative to password authentication is biometrics. Biometrics identify users by physical or behavioral characteristics such as fingerprints, voice prints, handwritten signatures, and facial characteristics. Smart cards are small plastic cards with built-in circuits containing processing logic to identify the cardholder. Unlike individual passwords, a database password is a string of characters that the database administrator assigns to a database and that users must enter before they can access the database. Authorization. The surety needs for a database are more individualized since different users tend to access the database for varying reasons. The database administrator can use authorization rules to specify which users have what types of access to which data. A user's permissions specify what kinds of access the user has to objects in the database. Permissions can be assigned to individual users or to groups of users. Work groups are groups of users. Views. A view is a snapshot of certain data in the database at a given moment in time. If a database management system provides a facility that allows users to have their own views of a database, this facility can be used for security purposes. Tables or fields to which the user does not have access in his or her view effectively do not exist for the user. Privacy. The terms security and privacy, though used synonymously, are different but related concepts. Privacy is the right of individuals to have certain information about them kept confidential. It is only through security measures that privacy can be guaranteed. Laws and regulations dictate some privacy rules, and organizations institute additional privacy rules. Data integrity features. A database management system must follow rules to ensure that data is accurately and consistently updated. These rules are known as integrity constraints and are categorized as either key integrity constraints or data integrity constraints. Key integrity constraints include foreign key and primary key constraints. Data integrity constraints consist of data type, legal values, and format. Integrity constraints can be handled in four ways. 1. Constraint is ignored, in which case no attempt is made to enforce the constraint. 2. Responsibility for constraint enfor- Responsibility for constraint enforcement is placed on users. That is, users must be careful that any update they make in the database do not violate the constraint. 3. Responsibility for constraint enforcement is placed on programmers. In other words, programmers place into programs the logic to enforce the constraint. 4. Responsibility for constraint enforcement is placed on the database management system. In this situation, the database administrator specifies the constraint to the database management system, which then rejects any attempt to update the database in a way that violates the constraint. Support data independence. A database management system must provide facilities to support the independence of programs from the structure of a database. Data independence is a property that can change the database structure without requiring to change programs that access the database. Types of changes which can be made to the database structure include adding a field, changing the field length, creating an index, adding or changing a relationship. Adding a field. If a new field is added to a database, there is no need to change any program except those programs using the new field. Note, however, that when a program using an SQL select from command to select all the fields from a given table, you are presented with an extra field. To avoid this, you need to list the required fields in an SQL select command instead of using the asterisk. Data replication. A database management system must manage multiple copies of the same data at multiple locations. Sometimes, data should be replicated or duplicated at more than one physical location for performance or other reasons. The existence of duplicate copies of the data at multiple physical locations results to ease of access and portability. Replication is a two-step phase. First, the database management system creates copies called replicas of the database at one or more sites. Secondly, the database management system exchanges all updated data between the master database and a replica. This is known as synchronization. Provide utility services. A database management system also provides a number of utility services that assist in the general maintenance of the database. Utility services that might be provided by a PC-based database management system include change database structure, add new indexes and delete indexes, use services available from operating system, export and import data, support for easy-to-use, edit, and query capabilities, screen generators, report generators, support for procedural and non-procedural languages. A procedural language must tell a computer precisely how a given task is to be accomplished. A non-procedural language is one which describes the task you want a computer to accomplish. And there should be an easy-to-use menu-driven or switchboard-driven interface. This week, you're expected to read Chapter 7 of the textbook, that is pages 231 to 255, complete Quiz 6, complete Assignment 6, complete Test 3, submit your final Project Progress Report 1, take part in Discussion 6. Please take note of the due dates and plan accordingly.